My name is Banu, working as an assistant professor, AI and AS department, SNS College of Engineering. So in the continuation of the previous video, we are here with the unit 1. The topic that we are seeing is introduction to deep learning. In the previous classes, we saw what is deep learning, why we are using deep learning, and what are the applications of deep learning and what is neuron. Now we will see like what is the correlation between a neuron and a neural network is. Okay. So now deep learning is based on the functionalities of a human brain. Let's understand how does an artificial neural networks look like. See, say for example, when you are going for any kind of process data, you want to get processing data, you want to get n number of data from outsource, right? It can either be from your students' friends or any other institutions, right? So you will be getting, say for example, if you're analyzing a project and you're doing a project and it analyzes the data. It analyzes the data and let us take a cancer detection of a patient, level of cancer affecting patients. You will get the data from a medical college, okay? Based on that data, you will be getting 150 data from an institution. Based on that, there will be 1 to 2 miscellaneous data, right? Likewise, the inputs that you are getting is nothing but x1, x2 till xn. The different kinds of miscellaneous data is nothing but w1, w2 till wn. The process that you are executing is called as a neuron, and the output that you get is the y. Here is the continuation or the comparison of different kinds of neurons and artificial neuron is the dendrites is actually connected to the inputs, the cell nucleus is connected to the nodes, the synapse is connected to the weights, the axon is connected to the output. Now, in the previous diagram, we saw how there are different inputs. The miscellaneous products is being or the miscellaneous data is being denoted as W1, W2 to Wn. The next thing is the neuron, right? In this, the neural networks will become in the biological term it was a neuron, but in this it is neural networks. The neural network is nothing but the transfer function and the activation function. Transfer function is nothing but the summation of the values which you get and the miscellaneous data that you have. Activation function is nothing but the different kinds of process of how you will be taking the data and doing the process. It can be different kinds of algorithms or whatever you are going to implement, and the output is the actual output that you are going to implement. Now, activation function takes the weighted sum of input plus the bias and input to the function and decides whether it should be fired or not. Activation functions are of 4 types: sigmoid, threshold, ReLU, and hyperbolic tangent function. Now the sigmoid function is something which varies from a value of 0 to 1. So now what is the 0 to 1? See, whenever you are getting a data, the data can be varied from minus or 0 to 1. Whenever you are taking a data of a student and a student database, he or she can score even fail marks or 0 marks or 1, right? So in this sigmoidal function, it takes the values between 0 and 1. In threshold value, if y value is greater than a certain value, the function is active or it is fired, which means they have given a value. Based on that, it will take, or if it exceeds, it will take, or it will not take. Now in this ReLU function, it will take based on the values it is the most widely used activation function and gives an output of x if x is positive and 0 or otherwise. Okay, it should be positive or 0. In this hyperbolic tangent function, it takes the values from -1 to 0 or 1. Okay. Now, in this activation function, you have different kinds of values like hidden value and the input layer value. Hidden value is nothing but the different kinds of activation value that you will be taken. Now, when I explain it with an example, you will be taking an image. Okay, that image will be based on the process. You have to train a data. Okay, You have to train a data or train a robot based on the segregations of dogs and cats. Okay, you will be giving n number of data to it. Okay, it will perform some of the activation function, that is a hidden layer based on it, and it will segregate the process based on dogs. It can be either be dogs or cats. So this is how the neural networks actually work. Now, what is this gradient descent? Gradient descent is an optimization algorithm for finding the minimum of a function. That is nothing but the minimum value that you will be taking it. Okay. Now, this diagram actually explains you like how it is being segregated, and how the process is being done. So this is all about like how activation function, neural networks, and the hidden layer works, the input and the bias function works. Okay, so as of now, thank you, have a good day.